Hey class, today we're going to be focusing on section 3.2, which are quadratic functions. We're going to take a look at their graphs and how to change them from one form to the other. Okay, so some of this stuff at the very beginning is going to be a review from when we actually graphed these for the last unit. So as we review, remember that a quadratic function, it's going to have the highest exponent of a 2, and that's called your degree. So your degree equals 2. It's going to graph a parabola. The shape of a parabola is a U-shaped curve. The parent graph of a parabola is y equals x to the second, or instead of y equals, you might have f of x equals. One form of a parabola is called standard form. Standard form is where you have y equals ax squared plus bx plus c. If it is in this form, to find the vertex, you use the formula for the x, negative b over 2a. Now the vertex is a point, so you have to have an x and a y, okay? To get the y value, you take whatever you got for the x and you plug it in, which is called a substitution. And once you plug that in, you'll put everything together and you will get your y value out from that substitution, and that will be your vertex. Now recall that if the parabola opens down, your vertex is going to be the maximum point. If the parabola opens up, your vertex is going to be the minimum point. So you're going to have an ordered pair with that vertex. Now your axis of symmetry is going to be a dotted vertical line that passes through the vertex. So what that means is the axis of symmetry with imaginary line going through the vertex, which means if you fold it on that line, the points on each side of that vertex will touch because they are symmetric. So for your axis of symmetry, it is a vertical line. So your equation would be x equals, okay? X equals graphs a vertical line, and it's going to go through the vertex like I just mentioned. So this is going to be passing through that x point, okay? So your equation is going to be x equals. So that graphs a vertical line. Okay, so make sure you remember it's going to be x equals. The direction of the parabola, if you're A, which is the leading coefficient, the one that leads the problem off when you put them in descending order, if your A is bigger than 0, that means that it has positive values. So that means the parabola is going to go upward. If your A is negative and less than 0, your parabola is going to go down. So think about that in terms of a positive person who is smiling and a negative person who is down, okay? Now, these are the key components right here that you can see that I'm kind of going over with you here. I have those underlined. So that dealt with direction. This one deals with size. So you always look at the absolute value, because if it's a negative, it's going to tell you that it goes down. It doesn't affect the size of the parabola. So if you have the A just equaling 1, the size is going to be normal. And you want to take the absolute value of what that A is. If A is bigger than 1, remember it's going to go up more. So if you were going up 5 and running 1, it would make it skinny. And we also talked about that stretching vertically. So remember we called that a stretch vertically. So that is if your A is bigger than 1. If it's between 0 and 1, and what that means is it would be some kind of fraction between those numbers, like 1/2, 1/10, that kind of thing. It's going to get wide, and we called that compress because it compresses away from the y-axis. So we call that compress vertically. Now, you can always compare those to the parent function when you're actually trying to look at those pictures with the size. You can see right here I have an x to the second typed in. This 1/10 x to the second is going to be between 0 and 1, so it's going to become wide when I graph it. So you see that's much wider than the parent. The parent is what you compare everything to. And remember, the parent graph is y equals x to the second. Now, if I was to flip it and put a negative in front of that, it's not going to change the size. It's just going to make that parabola go down. Okay? The size is still going to be wide. You can see it's the exact same size. It's just flipped. So think about it in terms of if you're hit with a negative situation, sometimes you flip out. So notice that parabola flipped out. It went upside down. Now, if I wanted it to stretch vertically and get skinnier, you can see the parent is the first one and the second one is much skinnier. Okay? So that deals with your size. Then you have your y-intercept and your x-intercept. Now, if you recall from algebra, your y-intercept is where the graph touches the y-axis. So if a graph is touching the y-axis, we'll say that we have a parabola right here. If this parabola touches the y-axis right there, I'm going to say that's the number 2. To name that, you would name that as 0, 2. That would be your y-intercept. So to name a y-intercept, your x is always 0, and then you have your y. You're able to find that y either algebraically or visually, looking at it on the graph. Okay, an x-intercept is where the graph touches the x-axis. Okay, right here, we're going to say that that's the number 1. So we'll say that one's 2 and this one's 1. So to name an x-intercept, you would put the x down and then the 0. So for the x, it goes in x's spot and 0 goes in y's spot. Okay, your domain for all parabolas that open up or down is going to be all real numbers. You can put any number in for x. You could flatten the parabola to the x-axis and the whole x-axis will be covered as long as you have arrows for continuity where it's continuing. Now the range. Let's say that the parabola opens up. We just discussed a while ago that would be your minimal. So if the parabola opens up, your y is going to be greater than or equal to whatever number that is. So let's just say that we have 4, 2. And it opens up, then your range is greater than or equal to that 2. So it's whatever number is your y coordinate of the vertex. So let's say the parabola goes down And let's say this vertex is 1, 3. So whatever your vertex is, that's your highest point right there, because that's going to be your max. That was your lowest y, so that's the min. So notice it goes up on both sides after that point. This goes down on both sides after that point. So if things are going down, it would be less than or equal to whatever number you're dealing with. So for our example that I made up, it would be less than or equal to 3. Okay, remember with the increasing and decreasing intervals, you're going to read the graph from left to right and look at your x-axis. Remember that increasing and decreasing intervals are always going to be open. So make sure you remember you don't bracket those. When you deal with the range, you would bracket that because that's included. The lowest number always goes to the left. So let me see, that was a 3, wasn't it? So you would bracket that number, but not the infinity. So if it's going down, it's going to negative infinity. But you're always going to look at the x-axis when you're actually looking at increasing and decreasing. So let's just look at just the parent function. So we're going to say that your y equals x to the second. So if you look at this graph from left to right, it's decreasing. So it would be decreasing, and you're going to look at it in terms of the x-axis. So it's decreasing from negative infinity to 0. Okay, so that's where it goes down. After 0, 0 is that turnaround point I told you, it starts increasing. So it increases at that point. So that point's neither increasing nor decreasing. And then you're looking at your x, remember, then it's going to positive infinity. So always look at your x-axis and always use what is called open intervals for that. Okay, before we look at this example, let's go to one more note here on this second page. Where the graph crosses the x-axis is the solution. Now, when you look at an x-axis, remember it's going to be this horizontal axis. Okay, there's some other words for that. It could be called x-intercepts. Okay, so it might say, what are the x-intercepts? It might say, what are the solutions? Those words mean, where is the parabola crossing the x-axis? That's going to tell you the answer. Okay, it might use this word here, which is roots. Think about what the root of the solution is. So it might be roots, and it's still where it crosses the x-axis. Another word that they use sometimes is zeros. Those words are all interchangeable. So it just means look at where the parabola is going to touch that x-axis. Okay, if I think about drawing a parabola, which is the U-shaped curve, the most times I can get it to touch the x-axis is twice. So it could cross 2 times. So that would have 2 solutions. I could draw it where it only touches once. That would be 1 solution. I could draw a parabola where it never crosses the x-axis, and that's called no real solution. Understand that these solutions are real. Okay, this one has no real. Where it crosses the x-axis is going to determine the number of real solutions you have. It does not determine the number of imaginary solutions you have. Okay? So make sure you understand those are reals. So we're going to try to graph this one. I notice that this parabola is in standard form. So I'm going to identify the A, which is 1. My B is -2. And my C is 3. Okay, go back to your formula on that first page in which I wrote. And remember, the first thing that you're going to find when you graph, the very first thing you need to find is the vertex. That is the most important thing to locate first. So I'm going to go ahead and use that formula to do that. That -b is going to be a negative of a -2 over 2 times 1. That negative times negative is a positive over 2, which reduces to 1. Now remember, I told you the vertex was an ordered pair. So what you have to do is you have to go back to the original problem, and you're going to put a 1 in place of that x to figure out the y. So I'm going to recopy the problem over, and I'm going to replace the x with a 1. So that's going to go to 1 minus 2 plus 3. That gives me -1 plus 3, which gives us a 2 for that vertex. Now, you can type that in the calculator. All I did was make a substitution. Now, once you have made a substitution, you want to make what's called an XY table. You want to graph 5 points, and you want to put the vertex as the third point, the point in the middle. When you pick your x's, try to go in order. So that would be like a 2, 3. And then if I go backwards, would be a 0 and -1. Now, when you put those numbers in, you would put those in place of x, so you could make substitutions for that. So I would put in a -1 to the second minus a 2 times a -1, and then I would add 3, and I get 6. 0 to the second minus 2 times 0 plus 3 would give me 3. 2 to the second minus 2 times 2 plus 3 is going to give me 3. Those are going to be your symmetric points. 3 to the second minus 2 times 3 plus 3 is going to give me that 6. Okay, when I draw this graph, I want to connect these with a U-shaped curve. So we'll have -1, 6, 0, 3, 1, 2, 2, 3, and 3, 6. So this will be that axis of symmetry that's going through that vertex. So we'll draw the parabola, and it's going upward. Okay, so I'm going to name those vocabulary terms. So we've got axis of symmetry. That's going to be that imaginary dotted vertical line that cuts through the vertex. So that's going to be written as x equals 1. For your domain, you could put any number in the world in for x, or you could flatten it to the x-axis. That would be all real numbers, negative to positive infinity. This graph has what's called a minimum, which is a low point. The minimum occurs at 2. So what that means, since my low point is at 2, my range is going to be numbers that are larger than 2. So to put that in interval notation would be bracket 2 to infinity. My size of this graph is going to be normal because my absolute value of a is 1. So that's normal compared to the parent function. My direction of this graph, if you notice, my a was positive, so it's going to be going upward. For my y-intercept, it's always going to be your c value. When you put in 0 for your x's, everything will cancel out but your c. So the y-intercept would be 0, 3. Your x-intercept, it's never going to touch your x-axis. So your x-intercept is none. So that means for your solutions, you have no real solutions for that graph. Now, when you look at that, another way you could actually go through this process is to type that into your y equals screen. So I can go to my y equals and I can type in the function I was given. And when I go to second graph, I'm able to look at that table to compare my answers. So you see I got those by hand and they're also checking out in the calculator. Then when you hit graph, you're able to see your parabola and you can compare that picture with the one that you have drawn by hand. Okay. Now, when you think of what is called a transformation, how this parabola moved from the origin, when you look at that, you base that on your vertex, because we're fixing to look at vertex form here in just a minute. So your vertex tells you that you went right 1 unit and up 2 units. So that's how this parabola moved. Remember, it's just like a shift. You're just taking something and moving it. So from this home point, you would slide it 1 place to the right and slide it 2 places up, okay? And that would be called your transformation, how it's transformed. The size, again, was normal. The direction's up, so it's not flipping out. Okay, so the last form we're going to look at today is called vertex form. Now, if you recall, when I worked that problem in standard form, I told you the first thing to try to find was the vertex, because the vertex helps you determine how to graph the picture. So once you have that vertex, it's kind of easy from that point. So if you can get a quadratic into what's called vertex form, then it's going to make it easier to graph, okay? This would be your vertex form. Y equals A, X minus H, quantity squared plus K. Okay, and we saw that when we were dealing in Unit 1 and we started moving the graphs around on the coordinate plane. Now, to get the vertex from that graph, the inside, if you recall, was always opposite the sign. So if it was a plus, remember that we moved left, and if it was a minus, we moved right. And this came from the inside of that function. So that would come from this portion right here. And think about that in terms of that H standing for horizontal. A horizontal move would be a left or a right move, okay? And the reason, remember, we change that is we take that and we set it equal to 0. So then it would make that H positive. So therefore it would be a right move, even though it was negative inside, okay? Now the outside is going to affect the vertical, okay? Remember, if it is a plus, it moves up, and if it is a minus, it moves down. So that's going to affect your vertical. That's your up or down. This one is going to affect your horizontal. when it's inside, which is left or right. Okay, and the last one is this A right here. That affects your direction. Remember, if it's positive, it goes up. If it's negative, it goes down. And it also affects the size, whether it's going to be skinny or narrow. Okay, so that your A is going to affect that too. So when you're filling this out, that's basically what I just went over right here. So if it's greater than 0, that means it is positive. So that means it's going to open up. If it's negative, it's going to open down. Now, with the absolute value, remember, if it's equal to 1, it's normal. Recall that you look at the positive of that number, because the negative is just going to tell you that it opens downward. If it's bigger than 1, remember it became skinny. So it was skinnier. If it was greater than 1, it was skinny. If it was between 0 and 1, remember it became wide. And then we have just normal, okay? Just your normal size. And that comes from your x to the second, where A is equal to 1. Okay? Now, when we start putting this stuff into vertex form, that's what we're going to focus on here at the very end of the lesson now. Sometimes it can get a little bit confusing until you get the steps down pat. So I've written these steps right here for you. And we're going to take a look at how those apply, okay? The very first thing you want to do is whatever number is in front of your quadratic term, which is the x to the second, you're going to take it out. You are only going to take it out of these first two terms. Whatever your constant number is, that's just going to be a regular number. C stands for constant. Whatever your constant number is, it stays hanging out there. Do not take out or factor anything from it. Then you start filling in the blanks. You take half of what your linear term is, which is your B. You're going to take half of it and you're going to square it. And it is going to go into that blank. You have to add or subtract the same number to both sides, because whatever you do to one side of an equation, you have to do to the other. So when you put this number in that blank, you have to add or subtract the same number to the other side. So you need to make sure that you distribute that A to that blank to know what to put over here. So make sure that you multiply that part. And then you factor and solve for y. Now, it sounds like a lot of steps, but it will get a lot easier as you practice this. Some of you might remember it from Algebra 2. Okay, so I put you a few extra sheets here that we're going to go through together, just in case some of you need this extra practice. So I'm going to go ahead and put the standard form that we started the lecture off with. And we're going to take that and we're going to try to put it in this vertex form. Make sure you start remembering those formulas and what we talk about today, because that will help you. Okay, now I'm going to go over here and kind of work out the problem and show you what's happening. So I'm just going to kind of take this problem right here and remind you that you leave that constant hanging out. So if you'll just put y plus blank equals, put your x squared plus 8x plus blank, and then put that 9 outside, because I'm going to walk you through with the steps I mentioned. Okay, after that part, you are going to take half of this number. So you're going to take half of your B term and you're going to square it. So I'm going to go down here and I'm going to put this information again. You always set the problem up with the blanks like this. Okay. And now we're going to take half of 8 and square it. So you can use your calculator and you can type the whole thing in like that. So 8 divided by 2 is 4, and 4 to the second power is 16. So I'm going to add the 16 to both sides. Okay. Now, another way that you might see someone do that is you notice that this typed up information already has it subtracting 16 because they're bringing it to the other side in a moment. I do that as a next step. Yes, ma'am. Okay, now I'm going to factor. Okay, when I factor this problem, you're going to take the trinomial and you're going to try to break it into two things that are identical.
Correct.
So we're going to have to do what's called reverse FOIL. So what you multiply to get x squared is x times x. To multiply to get 16 and add to get 8, so it has to multiply to be 16 and add to be 8 would be 4 and 4. So this part right here is going to factor to 4 and 4. So when you're factoring that trinomial. Okay, so I'm going to come on down here and I'm just going to bring that down. So I have y plus 16 equals, I can write that as a quantity squared because 4 times 4, that's the same thing multiplied to itself. Now, the last thing is you're trying to solve for y. So now this is where I subtract the 16 over. So my vertex form would be x plus 4 to the second minus 7. Now, to get your vertex from this problem, you're going to change the sign for the inside. The outside stays the same. So it would be -4, -7. That would be your vertex. Now, what this is telling you to do is if you take this original problem and you take the one that we just wrote, okay? If you take the original problem and the one that we just found, these two things should be identical. When you're transferring it to this, it's going to be the same problem or the same graph. So those things should be identical. So to check your answer, you can take your graphing calculator, and this would ensure that you've done it right, especially as you're learning. So I would type in the original problem. Then I would type in what I just got when I changed it to vertex form. And when I graph it, I should get the exact same picture. If you don't see another picture, that tells you that that parabola is the same because it's laying on top of itself. Okay, so if I go to the table, you see that the points are identical. So these two graphs should match when you're graphing to check those. So if you just need to do like a rough sketch or something like that, those should match you should have a vertex at -4, -7. So see, there would be like an axis of symmetry going through there. So that would be -4. I'm just going to kind of list these characteristics with you. My domain would be all real numbers. My range, so remember my vertex is -4, -7. After -7, the numbers go up. So it would be bracket -7 to infinity. And it has two solutions because it crosses the x-axis twice. The size would be normal because it has a 1 for the A. And then your minimum point, like I said, your minimum is your y coordinate. So that would be -7. Okay, let's look at the second page. And again, this is just kind of some typed up steps, and I'm going to go through in my words to show you how to do that. So I'm going to recopy the problem over here. If the original problem has an f of x equals, if it says on your assignment f of x equals that information, what I suggest you do is to put the y there because it makes it a lot simpler, because that means the same thing. Okay, the first thing that you want to do is, if you recall, you want to group those first two things together. This is where A is not equal to 1, okay? Notice that my A is not equal to 1. If the A is not equal to 1, you have to factor it out of the quadratic term and linear term. Okay, the quadratic term is the one with the 2, and the linear term is the one with the x. Sorry, my dogs are going crazy. Okay, so now I'm going to put y plus blank, like I mentioned. And when I say factor that out, we're going to take out whatever number that is as a GCF. So I'm going to pull out the -2, leave that constant number hanging. Okay. When I pull that -2 out, I should be left with an x to the second. Now be very careful because you're dividing both of these by -2. So when you take your 20 and you divide it by -2, you should get a -10. And recall, I told you to always put a plus blank. Okay. Now I'm going to fill in the blank. To fill in the blank, you take half of B and you square it. My B is -10. So I'm going to take half of -10 and square it. That's going to be -5. And when you square a negative, it becomes a positive. So I'm going to have a 25 for that blank. Okay. Now you've got to be very, very careful because you have to multiply that number to that because it has a -2 times it. So you have to multiply this number to that blank to figure out what to put here. So -2 times 25 is -50. Okay, so I'm going to come down here and I'm going to put plus -50.